Hi there. In this video, we're going to talk about how to find real and imaginary roots in polynomials. So in your notes there, we'll go ahead and fill in some of the blanks here, and then I'll show you some examples. The number of solutions or roots. Remember, solutions to an equation have lots of different names: solutions, roots, x-intercepts, solution set, zeros. They all mean the same thing. But most of the time I'm going to call them roots here. So the number of solutions or roots that a polynomial equation has is equal to its degree, and a degree of an equation, the degree of the polynomial is the highest power of the variable in the polynomial. So if you put the equation in standard form, whatever the highest exponent is, which will be on the left-hand side of the equation, is the degree of the polynomial. So there's real roots and imaginary roots. So if the polynomial is quadratic, in other words, the highest exponent of x is a 2, I'm going to look for something called the discriminant. And the discriminant is the value under the square root in the quadratic formula. So as you can see here on the right-hand side of the screen in orange, I wrote the quadratic formula. So once I plug in all the numbers, whatever that value turns out to be, if that number is positive or 0, then those are real roots. I'm going to have real roots for my equation. If they turn out to be 0, if that number turns out to be 0, then I'm also going to have some real roots. Now, this only works for quadratic equations. I'm going to show you how to do it when the highest exponent of x is higher than 2, but the discriminant is the number that you get under the radical in the quadratic formula. Another way you can do it is from the graph, and the graph of the polynomial, when it crosses or touches the x-axis, then those are real roots. So there's a couple different ways of telling real roots. We're going to use the graph a lot of times, but if you are using the quadratic formula, you can tell without looking at the graph how many real roots there are and what they are. All right, so if those are real roots, imaginary roots happen when the discriminant is negative. So if I get a negative number under the radical, which means I'm going to have an I in the answer, which is where the imaginary part comes from, then I'm going to have imaginary roots. Also, if the graph of the polynomial does not touch or cross the x-axis, then those are imaginary roots, and they always occur in pairs. Okay, so let's go ahead and figure out numbers of real and imaginary roots. Okay, so here's an example. So I want to find the real and imaginary roots for 2x cubed equals negative 4x squared plus 5. All right, so here's my procedure for determining my roots. And in this case, we're only going to determine the number of the roots. We're not going to actually figure out what the roots actually are. When you use the quadratic formula, or we were working with quadratics, we actually figured out what the roots are. In this topic right here, we're only figuring out how many of each particular root we have. We're not actually calculating what they are. First step I'm going to do is the same as when I had the quadratic formula. I'm going to write the polynomial in standard form, which means I'm going to put the highest exponent of x first and equal everything to 0. All right, so for this example, even though I have 2 terms on the right-hand side and 1 term on the left-hand side, I'm actually going to keep the 2x cubed where it is because it's positive. Remember when I use, when we're putting quadratics in standard form, I always wanted the highest, the term with the highest exponent to be positive. I'm going to do the same thing here. So we have 2x cubed, and then I'm going to add 4x squared to both sides, and I'm going to subtract 5 from both sides, and equals 0. So that's standard form. All right, now I'm going to find the total number of roots, which is the degree of the equation, by finding the highest exponent. Well, that's pretty easy here. It's the exponent of the term on the left-hand side. So remember, I go from highest exponent to lowest, and the degree or total number of roots in this case is 3. All right, next step, I'm going to graph the polynomial. And there's the graph. So remember, when you type it into Desmos, you don't want to type the equals 0 part. So there's the graph. Now, step 4 says count the number of times the graph crosses the x-axis. These are the real roots. So if I go back to the graph, I can see that it crosses the x-axis one time and one time only. So that means it has one real root. All right, so for real roots, that's 1. Okay, so again, total comes from the highest exponent. The number of real roots comes from how many times it crosses the x-axis. Now, the imaginary roots I get when I subtract the number of real roots from the total roots. Okay, so you can think about it this way. I'm going to take the total, subtract from it the number of real roots, and that's going to give me the number of imaginary roots. Okay, so if I go back to step 2, I found that I have 3 total roots in this equation. There is 1 real root. I'm going to subtract 1 from 3, and I get 2. So the number of imaginary roots in this polynomial is 2. Okay, so this is going to be a good thing to remember. You might want to jot that down in your notes and make a highlight of it, because that's the way you're going to kind of do each of these problems, and you're going to do it in that order. Find the total, find the real, and then from those two, you can then calculate the imaginary roots. All right, so let's do the 3 example problems you have there. All right, so for the first example problem, I put it in the standard form. Remember, in Desmos, I don't want to type an equals 0 at the end. So first thing I'm going to find is the total number of roots, and that's going to come from the highest exponent of the variable, and I can see right here, that's going to be 3. I'm going to subtract the number of real roots, and in this graph right here, I can only see 1 real root. It only crosses the x-axis once, so 3 minus 1, there's 1 real root, so 3 minus 1 means that there are 2 imaginary roots for this problem. So very similar to the last problem, different graphs, but similar number of roots. We're not going to actually, again, figure out what the imaginary roots are. If it's a quadratic equation, you can use the quadratic formula to figure out imaginary roots, but for a polynomial equation like this, where the highest exponent is 3 or higher, that is beyond Algebra 2 for how to find what those imaginary roots are, so we're not going to do that. We're just going to count the numbers. All right, next example, so it's example number 2. I've put the polynomial into standard form. Again, didn't type the equals 0 in. All right, so I'm going to do real. Nope, sorry. I'm going to start with the total. Remember, that's first. So the total minus the real, and that's going to give us the number of imaginary roots. So let's start with the total. The total comes from the highest exponent of the variable, which is 6. The real roots are the number of times that it crosses the x-axis. So there's 1, there's 2. So I'm going to subtract 2 from 6. 6 minus 2 is going to give me 4. There are 4 imaginary roots for this polynomial. And remember what I said back in the notes, the imaginaries always occur in pairs. So if I got the number of imaginary roots to be like 1 or 3 or 7, then I know I did something wrong. It should always be an even number. So it can be 0, but it should also be an even number. So 0, 2, 4, 6, and so on. All right, last example there. I put in standard form. So we're going to do total minus the real equals imaginary. So I'm going to start with the total number of roots. It comes from the highest exponent of the variable, which is 4. In this case, the graph does not cross the x-axis. Here's the x-axis down here. The graph never comes near it. So there are 0 real roots. I don't have any of them. And so that means all of the roots in this problem are imaginary. So there are 4 imaginary roots.